Welcome to Khetz Tutorials, and in this video, I'll be doing question 18 from 1.4 exercises in James Stewart calculus. So we're asked to find the equations that would result from us doing the following. First, we're asked to reflect y equals to e to the power x about the line y equals to 4. So I advise that you take it in steps. I'm going to show you what the final graph would look like, and we're going to take it in steps to get to that point. So your y equals to e to the power x looks like this. Then your line y equals to 4 perhaps would be there if that point there is 4. And we're asked to reflect this red line about it. So we just have a mirror image. It's nothing really major. This is something that you know. But instead of now having the x, so this is the x-axis, as our line which we reflect about, we're reflecting about the green line. So that's the only difference. So this green line is a mirror. It's our new mirror which we use to reflect, and the distance between the graph and it should be the same even on the other side. For example, this is 1. So the distance between this 1 and the green line is 3. So after reflecting, the distance between 4 and that point there should be the same, should be 3 as well. So that would be 7 up there. So that is our final point. That is what we're aiming for when we reflect about y equals to 4. But what is the equation of that? To find it, we can use what we already know. Firstly, we're going to reflect about the x-axis. So we're going to reflect the red line about the mirror that we know how to reflect about. That would be the x-axis, which means the mirror image would be down here and it would look like this. And here would have -1. So this is y equals to negative e to the power x. So that is a reflection about the x-axis. All right. So the question now is, how can we take this and move it up to the yellow position? And the answer is you're going to add 8. So if you shift this reflection up by 8, you're going to land at 7 over there, which is where you need to go. So the equation for the first question would be y equals 8 added to the reflection about the x-axis, which you already know. So the blue line is a reflection about the y, the x-axis. Then if you shift that by 8 upwards, you're going to land in the yellow graph's position, which is the graph which we're looking for. So that's how you'd find the equation. First, do what you know, then shift that to fit or to be on the target, basically. And let's do the same for the next question. So the next question B says we're reflecting about the line x equals to 2. So now we're focusing on the y. The line x equals to 2 perhaps would be there. Let's say that is 2, and this is the x-axis. This is the y-axis. Once again, we're going to have original function, and it crosses at 1. And if we were to reflect this about the y-axis, then it would just look like this. It would be a mirror image of itself, still crosses at the same point, right? But now that's not what we're aiming for. That's not what we're doing. We are now reflecting it about the green line, and the reflection would perhaps look like this because we're reflecting about that green line. Okay, so if you look at the distance between this point and the green line, it's 2 units. So this is 0, then that is 2. That distance is 2 units. So this here will be at 4 because that distance has to be maintained. The distance between the mirror, which we are reflecting about, and each of the images has to be the same. So if the distance from this, the original, the red one, to the green line, which we're using for reflection, is 2, and the distance from the mirror, the green line, and the new position, which is a reflection about x equals to 2, also has to have a distance of 2. So that would mean that that point there is 4. All right. So the white graph is y equals to e to the power negative x. So that is what we know. If we reflect the original y equals to e to the power x about the y-axis, we're going to have this because we're going to negate the x. Then the question is, how can we move the white graph to the yellow one's position? And the answer is, we're currently at an x of 0. We want to get to an x of 4. So that would require us to shift this by 4 units to the right. Okay, so if you do that, then we're just going to shift this by 4 units to the right, and the resultant function would be us having e to the power minus x, but we're going to add a 4 to it. So we have the reflection about the y-axis, but we're going to add 4 units to it so that it shifts to the point here, the yellow graph that we have over there. All right, so this might be a bit confusing because you usually know that when you go to the right, you're going to have f of x minus 4. So we can apply this. Remember, we had a reflection about the y, which looked like this. And now we're saying that we're moving this to the right by 4 units. So we're going to substitute x minus 4 because we're going to the right. So if you do that, then the result will be as follows. We're going to have e to the power x minus 4. And this would be y equals to e to the power minus x plus 4, which is the same as what we have there. We just started with a 4 in this case. So if you also want to take it in steps like that, you can do so. Remember that when you go to the right, you're going to have x minus 4 and not x plus 4. Substitute that in place of x, and you'd have your shift to the right as you should.